Hello everyone. In this video we will discuss about carboxylic acids, right? So what are carboxylic acids? So carboxylic acid is a functional group that has this particular group attached to it. So this is a carboxylic acid. So you have seen this particular group and we call this carbonyl group. And where have you seen this before? So you have seen this carbonyl group in your aldehyde or ketones, right? So you have seen this particular group in your aldehydes or ketones. The other group that present in the carboxylic acid is the OH group. And this particular we have seen. So this is our hydroxy group. Some people like to call it hydroxyl. So you can call it hydroxy or hydroxyl. It doesn't matter. Both are correct. Okay, so this is our hydroxy group. And where have I seen this before? So we have seen this in our alcohol. So we have seen this in our alcohol compounds. So when you have both of this like this whole thing is called our carboxylic acids. And the entire thing is called as carboxyl group. So again, quick recap. So this portion is called carbonyl group, and this portion is our hydroxy group or hydroxyl group. So together, this whole thing is called as a carboxyl group. And when you have a carboxyl group in our molecule, then that becomes a carboxylic acid. So the naming is pretty straightforward. So if we have alkane, so the E is replaced by oic acid. Oic acid. So in summary, we can write this like alkane. So replace the E with oic acid. So it's called alkanoic acid, right? So let's do an example. So let's do a one carbon atoms. So this is the simplest. This is the simplest carboxylic acid you can have. So where on one side you have hydrogen. So how many carbon atom we have? So we have one carbon atom in this compound. So one carbon atom is methane, but then E would be replaced by oic acid. So it's methanoic acid. So there is a common name. So this is the IUPAC name or systematic name. So this is our IUPAC name. But there is also a common name. You don't need to know all the common names, but it's kind of good if you know a couple of them. So this is the common name for this one is formic acid. So just know two of them. So this one present in ant. So that's why when ant bites, it gets a sting because of this formic acid. It's like a small acid bond that you're getting from your ant. Well, not your ant, regular ant. Okay, so that's the easy one. So if we have two carbon atom, so I'm gonna redraw this one, COOH, and on the left, I'm gonna add CH3. So this is a two carbon atom. So two carbon atom is ethane. Then E is replaced by oic acid. So this is ethanoic acid. The common name for this one is called acetic acid. And where we use this is what makes vinegar, right? Vinegar is basically a diluted solution of acetic acid. So this is present in vinegar. All right, so we'll keep going. Three carbon atoms. So let's say CH3, CH2, COOH. So you have three carbon atoms, 1, 2, 3. So it's propane, but then E would be replaced by oic acid. So it's propanoic acid, right? Okay, this is how you should name systematically. So you got propanoic acid, butanoic acid, pentanoic acid, hexanoic acid. In terms of priority, this one always get the highest priority. So the carboxyl group always get the first priorities. So you don't need to number any one of them if there is nothing else is in there. So it's always gonna be one. So if it's always gonna be 1, 2, 3, so you don't need to number them because it's by default one, right? But if you have multiple group, uh, like if it's combinations with aldehyde, then you might have to number them. But your goal is this one always gonna be higher priority. So if you remember from our earlier videos, uh, like the chloro, so the so halogen get the least priorities, alkane get the alkyl group got the next priorities, then we have alcohol, which is next higher priorities, then ketone is the next priorities, aldehyde is the next priorities. So this is the priority order. So if this means if you have multiple groups, then who would you give the smaller number? So whoever is the higher in the chain of command is going to get the first priorities. And the carboxylic acid is the highest so far. Okay, let's do a nomenclature. So the basic rule is exactly the same so far what you have learned. So let's do something like this. Okay, so I'm gonna add hydrogens, H, H, H. Okay, so how would you name this? So first rule, find the longest chain containing the carbon atom. So longest carbon chain with the highest priority group. In this case, the highest priority is carboxylic acid. So COOH. This is the right way to do it too. If you don't want to write like this, COOH, so you can write like this. Find the longest carbon chain with the COH. So what is in this case? So the answer is we got 1, 2, 3, 4, 5. So we got 5 carbon atoms. So 5 carbon atom means the parent name is gonna be, so write down the parent name. So it is pentane, but the E would be replaced by oic acid. So that is the parent name, pentanoic acid. So next thing you're gonna look at is substituent. So what is the substituent here? Substituent is methyl. So that is our substituent, 1 carbon atom, which is methyl. Substituent is methyl. So where do we write the substituent? Before the name, right? So it's gonna be methyl pentanoic acid. So acid is always gonna be the first priority. So that's 1, 2, 3, 4, 5. So where exactly the methyl group is? The methyl group is on the 4th locations. So it's gonna be 4-methyl pentanoic acid. All right. Okay, let's do one last. So let's say we're gonna do 1, 2, 3. Okay, so this is a little bit complicated or a little bit harder one. Okay, so first thing that you want to find out is what are the functional group. So this whole thing, COOH, is our carboxyl group. So this is our carboxyl group, or you can call it carboxylic acid. So this is the class of compound, which is our carboxylic acid. And this one, what is the class of compound? This is our carbonyl. Carbonyl, and this one is part of a ketone. All right. So if we go our priority table, so we got two groups, ketone and a carboxylic acid. So who should get the higher priority? So carboxylic acid is higher in the chain, so carboxylic acid that becomes the parent, and the ketone would act as a substituent. So when ketone act as a substituent, uh, we call this as oxo. Alcohol is hydroxy, right? Alkane is alkyl. Halogen we know is halo, and aldehyde you can call it formyl. So let's not worry about this for now. Okay, so how many carbon atoms we got? We got one, two, three carbon atoms. So parent name is gonna be propane, but the E would be replaced by oic acid. So it's propanoic acid. What is the substituent? Substituent is a carbonyl. Carbonyl, which is a ketone. If it's a ketone, we call it oxo. And what is the location of the oxo? So this carbon atom always gonna be 1. This has to 2, 3. So it's gonna be, the name would be 2-oxo propanoic acid. All right, 2-oxo-propanoic acids. How about this one? C, 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 C. Okay, so this is also a carboxylic acids. So we have 4 carbon atoms, so it's a butane. So last E would be replaced by oic acid, butanoic acid. And what is the substituent here? Substituent is chloro. So the name would be chlorobutanoic acid. Chlorobutanoic acid. And where is the location of this going to be? 1, 2, 3, 4. So it's gonna be 4 chlorobutanoic acids. So whoever is the highest priority, that's the one gonna get the smallest number. So you're gonna play by the rule of that higher priority groups. All right, so let's stop here.